the expansion of the Internet, 5G applications, and scenarios, and the rapid development of AI large models, the basic computing facilities of major operators and manufacturers are presented. Severe high-power heat dissipation challenge: how to deal with high-power consumption and efficient heat removal become an urgent problem to be solved. Conventional cooling schemes include air-cooled radiators, heat pipes, soaking plates, and so on. However, the traditional heat dissipation method is obviously not enough to cope with the growing heat dissipation needs. New cooling solutions are emerging. 3D-VC 3D soaking plate heat dissipation is one of them. Compared with the traditional VC soaking plate and heat pipe, 3D-VC radiator has little difference in material and working medium. The material is copper and the common working medium is pure water. What really makes 3D-VC radiator stand out is its efficient heat dissipation efficiency. Heat pipe is a one-dimensional linear heat transfer device. Conventional VC soaking plate, because of the existence of evaporation and condensation section, depending on the design location, there are multiple distribution possibilities in the heat dissipation path. This makes the conventional VC soaking plate a two-dimensional heat transfer device, but its heat dissipation path is still confined to the same plane. Heat pipes with one-dimensional heat conduction, two-dimensional heat conduction, VC soaking plate compared. The heat conduction path of the 3D-VC radiator is three-dimensional, stereoscopic, non-planar. 3D-VC radiator uses VC. The combination of heat pipes allows the internal cavity to communicate through the capillary structure to achieve the working fluid reflux. Complete the heat conduction. Connected internal cavities plus welded fins make up the entire cooling module. The heat dissipation module can realize multi-dimensional heat dissipation, such as horizontal and vertical. Multi-dimensional heat dissipation path makes 3D-VC heat sink. When dealing with the heat of high-power devices, access to more heat sources provides more heat dissipation paths. The heat pipe and VC temperature equalizing plate. In traditional heat dissipation module, since the thermal resistance value increases with the increase of the heat conduction distance, the heat dissipation effect is not very ideal. The 3D-VC radiator extends the heat pipe into the body of the VC soaking plate. After the vacuum chamber of the VC temperature equalizing plate is connected with the heat pipe, the internal working medium is connected. The 3D-VC radiator is in direct contact with the heat source. The vertical heat pipe design also increases the speed of heat transfer. 3D-VC radiator three-dimensional structure with efficient heat dissipation, uniform temperature distribution, reduce hot spots and meet the requirements of fast heat dissipation and fast temperature equalization of modern high-power devices. At present, 3D-VC radiator is an emerging heat dissipation method, mainly used in servers, base stations, and other high-power devices that require high heat dissipation efficiency. Once the heat dissipation of this type of device facility is not timely, the result is also more serious. The demand for 3D-VC heat sinks in the era of integrated high-energy consumption is predictable. The application scenario of 3D-VC radiator makes it necessary to pay special attention to product performance and quality in production.